Good afternoon, everyone. So, welcome to your lecture number 3. In the last 2 lectures, we have been discussing about the prime factorization of the number. Today, we are going to discuss the factorization, right? So, that means we can have the other factors as well. Now, let's start with the first question. First question is, write all factors of the number 48. Right? A very small number, you can definitely write the factors, not a big deal. So, first of all, obviously, 1 is the factor of 48, then 2 is the factor of 48 because it's an even number. Then let's check whether this is divisible by 3 or not. Since sum of the digits is divisible by 3, 3 is a factor. 4 is obviously a factor. 5, no, of course not. 6, since 2 and 3, they are factors, that means 6 will be the factor. 7, no. 8, yes. Then 12. Then 16, then 24, then 48. Right? Just check that I have missed out any factors. I hope so, not. Right? So, let's move on to the next one. Since it was such a tiny number, I can just elucidate all the factors like this. And I should say enumerate, not elucidate. Right? So, let me change the number. Let me make it a bigger number. Now, if I ask you write all factors of 252. Right now. Write all factors of 252 now. Now the thing is, if you move on like this, 1 is the factor, then 2 is the factor, 3 is the factor, 4 is it the factor? Yes. And so on. Since the number is large, there might be a possibility that you'll miss out one of the factors. Right? There's a high chance of error in this case. That means we need to have a better solution. We need to have a better method. Right? Okay, my question is about the factors of the number, right? So, I need to study this number. In short, if I can study the parts of it, I can talk about the factors. Now, whenever parts of a number come out, in fact, whenever parts of a natural number is talked about, we go to its prime factorization, right? I'm sure you can have the prime factorization of 252 as 2 square into 3 square into 7. Not a big deal, you can find it out. Right? Now, with the help of this, now try to write all the factors. Alright, you can obviously pause the video and write it down, but I'll move ahead. Now, let me just try to analyze it. Any factor of this number might have a factor of 2, right? Prime factor can be 2. It might have a prime factor 3. Now, obviously, it will not have a prime factor 5 because obviously I didn't, right? Then prime factor 7. Any factor of this number would look like 2, it might have prime factor 2 or some part of it, or it might have prime factor 3 or some part of it, it might have prime factor 7 or some part of it. Right? Okay. Now, I'll change my question. Write all factors, I said. In fact, now let me change it. Write those factors which contain 2 squares. Right? Because obviously in the factors of this number there will be some factors which would have 2 squares. So write down those factors. Right? I think sufficient time. Now you will say, ma'am, 1 factor is 2 squares itself. Okay, makes sense. Now along with 2 square I can have some other prime factor as well. So let me put 2 squares and I'll put 3. Right? That is also the factor of this one. You can see this is divisible by this. Then I can put 2 square, I can have 3 square. Then 7 is there, so maybe I can have 2 square with 7. Right? Or maybe I can have all of them together. 2 square, 3 and 7. Then I can have 2 square, 3 square and 7. Now the thing is, if I write like this, it's a little bit haphazard and I might miss out the cases again. Right? I will have a better method. Now, look at this carefully. If 2 square is there, the long factor can either be 3 or it can be 7 or it can be 4. So let me just take this into account and have a better method. Right? Now, the factor containing 2 square would have 2 square, right? Along with it, I might have a factor of 3, right? So along with this, I can have 3 square. Obviously, I cannot have 3 cube over here because 3 cube is not present in this factorization itself. So I can have 3 square. Along with this, I could have gotten 3 raised to 1 as well. Or there is the possibility, as you saw, that there is no factor of 3, so maybe I can have 3 raised power 0. Right? So 2 square can be associated with this, or this. Right? Now, I have talked about factor of 2 square. In fact, I have talked about factor of 3. Now, let me talk about factor of 7. Okay? Now, with this, when I have taken 2 square and 3 square together, either 7 can be there. In fact, I should say 7 raised power 1, because that is the part that is available. Or it might not be present, so I can have 7 raised power 3. Right? Along with this, either I can have this or this. Right? But I could have taken my factor as this one as well, this and this. Right? Along with this, I might have 7, I might not have 7. Now, along with this, I can have 7, I cannot have 7. Right? If you write the factors which have 2 square in this manner, it is guaranteed you will not miss out anything. Right? So, let me write the factors now. Now, if I need to read the factors, the first factor I'll read it as 2 square, 3 square, 7 raised power 1. So, this is 2 square into 3 square into 7 raised power 1. This is how you read the factor. Second factor read kare, 2 square, 3 square into 7 raised power 0. So, 2 square into 3 square into 7 raised power 0 is nothing but 1. Right? Then this one, 2 square into 3 into 7. So, 2 square into 3 into 7. Then 2 square into 3 raised power 1 into 7 raised power 0, which is 1. So, 2 square into 3 raised power 1. Then next is 2 square 3 raised power 0, which is 1 into 7 raised power 1. So, 2 square into 7 raised power 1. Then 2 square 3 raised power 0, 1, 7 raised power 0, 1. So, this is nothing but 2 square. That's it. 1 tha, to maine dekha. Right? From here, you will obviously get the number 252. You can write it, because write all the factors. You cannot leave the factors like this. You need to multiply as well, right? Then 4 into 9, that is 36. Then 4 into 3, 12, 12 into 7, 84. Then 4 into 3, 12. 4 into 7, 28. Then I have 4. These are all the factors which contain 2 square. Right? Now, wait a second. Along with 2 square, let me see. Can you write all the factors which contain 2 raised power 1? Write it down. Now make this thing on your own. Right? And I'll erase this because I need the board, but you can multiply it and write it down on your notebook. Right? Write all those factors which contain 2 raised power 1 now. Hurry up. You can pause the video and move along. Okay. Right, last 10 seconds. Cool. Right, I think sufficient time. Now, along with 2 raised power 1, I can have factors of 3. Right, now the maximum power of 3, that can be 3 square. Or I can have 3 raised power 1, or I can have 3 raised power 0. So again, I'll not bifurcate it, trifurcate it. I don't know if that is a word or not, but okay. So this is 3 square, this is 3 raised power 1, this is 3 raised power 0. Now, this can be associated with 7 raised power 1, or it can be associated with 7 raised power 0. Then again, 7 raised power 1, then 7 raised power 0, then 7 raised power 1, then 7 raised power 0. Right? I have talked about the factors which contain 2 square, which contain 2 raised power 1. Now, there is just one case which does not contain 2 at all. Or maybe I can say which contains 2 raised power 0. Right? Okay, so make that branch again. 2 raised power 0 can be associated with 3. 3 square, 3 raised power 1, 3 raised power 0. From here, 7 raised power 1, 7 raised power 0. From here, again. From here, again. Right? Now, again, you need to write the factors. So, my factor would look something like this. This into this into this. So, 2 raised power 1 into 3 square into 7 raised power 1. Then this into this into this. So, 2 raised power 1 into 3 square. Then this. 2 raised power 1 into 3 raised power 1 into 7 raised power 1. This, and this. So 2 raised power 1 into 3 raised power 1. Just, you know. And 2 raised power 1, 3 raised power 0, we don't care. 2 raised power 1 into 7 raised power 1. Then 2 raised power 1, this is 1, so 2 raised power 1. You can obviously multiply it and write it down. Again, you will write it. So I will write it quickly because we don't have much time. So yeah. So this is 3 square into 7 raised power 1. This is 3 square. This is 3 raised to power 1 into 7 raised to power 1, then 3 raised to power 1, then 7 raised to power 1, and lastly 1. Right? We have written all the factors of 252. Case is exhausted. Right? If you write the factors in this manner, it is guaranteed you will not miss out anything provided you have good concentration. That is also important. Right? So you can again multiply it and write it down. Now, if I ask you what is this method called? Now, I know this thing is opening up like a branch, or you can say like a tree. It's like a vertical tree if you want to call it. Then vertical tree, no, I should say horizontal tree. Horizontal tree, horizontal tree. Right? You can check in your book what this method is called. But I think it is called factor tree, but don't take me on it. Cool? Right. Let's move on. Now, the next question is, if I ask you, how many factors are there of 252? Right? So, yeah, how many factors are there? How many factors of 252 are there? Right. Let's see. How many are there? 1, 2, 3, 4, 5, 6. 6 factors. Count these. 6 factors. Count these. 6 factors. So 6 plus 6 plus 6, that is 18. Right? Okay. Now, if I ask you, write the number of proper factors. I'm not talking about factors, I am talking about proper factors. Now, you should know the term proper factors. Right? Proper factors are all those factors excluding the number itself. Right? So, you need to consider all the factors excluding the number. That means this one. So 18 in total, I just need to exclude 1, so that means the answer should be 17. And you should know this terminology, which is proper factors. Right? Now, if I ask you instead of proper factors, how many non-trivial factors are there? Non-trivial. Come on. Non-trivial factors. Now, think about non-trivial. So when a trivial person, what will trivial factors be? Even if I do not know the terminology, I have common sense and I know a little bit of English, right? So, trivial. Something that will be no matter what. Right? Now, I do not need to check whether 1 is a factor of 252 or not. It will be a factor. And I do not need to check whether 252 is a factor of this or not. Right? The number itself. Obviously, 1 and the number itself would be the factor of 252. These are trivial factors. Now here there is non-trivial ones. So all those factors excluding these two. So all those as in 18 minus 2, that is 16. Alright. Now, if I ask you how many integral factors are there? Integral. Now what answer would be? Right, integral factors. Now I know that, let's see. Now, can you say that 4 is the factor of 252? Yes. Now, since I'm talking about integers can be negative as well. Would you say that minus 4 is also the factor? Yes. When I'm talking about the integral factors, because I mentioned it, I will also say that minus 4 is also the factor of this. Right? Okay, from here, this is 12 is the factor. Do you think minus 12 will be the factor? Answer is yes. Right? Do you think minus 28 will be the factor? Yes. In fact, from all of these, if I take the negation of that, that will give me another set of factors. So, how many will there be? 18 these, 18 those, 18 plus 18, that is 36. Right? Now, the next question is, write those factors of 252 which are divisible by 3. In fact, write both out. So, write. Next question, write those factors of 252 which are divisible by 3. I've written all the factors by the way, it's on the board and I'm sure it's in your notebooks as well. Divisible by 3. 3 से divisible होना चाहिए. Come on. Done? I hope so. Right? Now let's consider this factor. Do you think this factor is divisible by 3? Obviously, it has a factor of 3 square. It will be divisible by 3. Okay. I found one. You can write it whatever it is, which is 252 by the way. Do you think this factor is divisible by 3? Yes. You can see 3 square. Do you think this factor is divisible by 3? Yes. Do you think this one? Yes. This one? Absolutely not. This does not have any factor of 3. Careful. So I don't want this. This one? Again, I don't want it. Doesn't have a factor of 3. Done? Okay. What about this one? Yes, 3 square is there. Divisible by 3, divisible by 3, divisible by 3. What about this one? No, it doesn't have a factor of 3. Doesn't have a factor of 3. Then this. Right? In fact, I can see 4 plus 4 plus 4. The answer is 12. No, the answer is definitely not 12. I said write those factors. So write these factors. Multiply them, write these factors. And you'll get the answer. Right? I will leave that up to you. Cool? Next question is, write those factors of 252 which are not divisible by 7. Careful, not divisible by 7. Hurry up. Not divisible. I think sufficient time. Right? Let me consider this factor. Do you think this is divisible by 7? Yes, I can see it. But I want not divisible. So do I want this factor? No. Right? What about this one? Is it divisible by 7? No. That means it is not divisible by 7. That means I need it. So 1. Right? Divisible by 7, I don't want it. Not divisible by 7, I want it. Now this one, divisible by 7, do not want it. Not divisible by 7, want it. Right? In fact, I am getting 3 from here. You can see I want this one, this one, this one. 3 again, then this one, this one, this one. 3 again. The answer, you multiply it and that will be the answer, and those factors will be 9 in number. Right? Now, next one. Write those factors of 252 which are divisible by 2 but not by 3. But not by 3. Now careful. Divisible by 2 but not by 3. Hurry up. I think sufficient time. Right? Now, divisible by 2. If I take any factor in this branch, do you think it will be divisible by 2? Of course. This branch has 2 square as a factor, right? Definitely divisible by 2. Okay. Now he says fine, but not divisible by 3. If I consider this factor, do you think this is divisible by 3? Of course it is. 3 square is there. This one, 3 square is there. Do not want it. 3 is there. 3 is there. What about this factor? This is not divisible by 3, so that means I want this. Divisible by 2, not by 3, I want it. Now this one, definitely divisible by 2, not by 3, I want it. Right? Now here, again, now if I consider this branch, it has the factor 2 raised to 1. Do you think it is divisible by 2? Answer is yes. So all these factors satisfy the first condition. Now the second condition is not by 3. So this is divisible by 3, divisible by 3, divisible by 3, divisible by 3. These two are the only ones which are not divisible by 3. Right? Now the next one. Now this has 2 raised by 0. Do you think it has a factor of 2? No. That means all of these factors are those factors which are not divisible by 2. Is the first condition satisfied? No. Now if the first condition is not being satisfied, I will not even check over here. So in this case, I have this the answer, this the answer, this the answer, this the answer. That means 4 in total, but you need to write those because that is the question. Right? Now, I think this was clear to everyone. So we'll move on to next set of questions now. Next question is, write down, using prime factorization. Using prime factorization, find HCF of 252 and 420. As fast as you can without any error, because if you commit an error in this question, you'll have a problem. Hurry up. Alright, I think sufficient time. Now he said, on the board now, He said using prime factorization, I need to find the HCF. So that means I need to prime factorize the number. Now 252 we just prime factorize this. That was the number 2 square into 3 square into 7. And 420 we can factorize it as 2 square into 3 into 5 into 7. Now HCF. The word HCF stands for what? HCF stands for highest common factor. That means if I take common factors of 252 and 420, all those common factors, I want the largest or the highest of them. And that will be the HCF. Right? Now he's talking about the common factors. HCF निकाल. Now, 2 square is present over here, 2 square is present over here. Do you think in the common factor I would have 2 square? Yes. Do you think in HCF, highest common factor, I would have 2 square? Yes. Right? Now, let's talk about 3. Here I have 3 square, here I have 3 raised by 1. In the common factor, will I have 3 raised by 1? Yes. In the HCF, do you think I'll have 3 raised by 1? Yes. Okay. 7 raised by 1 is present over here, 7 raised by is present over here. Do you think in the common factors I will have 7 raised by 1? The answer is yes. In the highest common factor? Yes. Now, okay, this is done. Now, 5 is here. 5 is not over here. Do you think I will have 5 in the common factor? A common factor में नहीं होगा तो highest common factor में कैसे होगा? So that means I have written all the factors of the HCF and this is the answer, which is 21 into 4, which is 84. Right? Alright. Next one. 2 positive integers. Write down 2 positive integers C and D are written as C as p raised by 5 into q raised by 3, D as p square into q raised by 5, where obviously p and q are distinct primes. You need to find the HCF of C and D. Hurry up. I think sufficient time because the answer dikh hi raha tha. Right? Now C, so basically when I say that C is p raised by 5 into q raised by 3, these two are primes. I have prime factorized C. I have prime factorized D. Cool? Now in the HCF, let's see. Here I have p raised by 5, here I have p square. In the highest common factor, I will have what? P square. Right? Now, q raised by 3, q raised by 5. In HCF, highest common factor, that means I will get q, which is the answer. That's why I didn't give you much time. Next question. Find HCF of 36 raised by p, 45 raised by p, where p is any positive integer. Come on, I should get the correct answers. I think sufficient time. There's nothing to do in this question. Now he says find the HCF of these two numbers. First of all, since HCF is getting involved, I need to prime factorize the number. So my first number is 36 raised by p. First of all, I'll prime factorize 36, which is 6 square, or I can say 2 square into 3 square. Right? Whole raised by p. Now, laws of exponents I already know because I know ab raised by m is a raised by m into b raised by m. So this becomes 2 raised by 2 square raised by p into 3 square raised by p, or I can write this as 2 raised by, now this gets multiplied to p, into 3 raised by, this gets multiplied to p. Right? I have written 2 additional steps which you need to write in your school exam. So there it is. Don't skip that in your school exam. Right? The next one is 45 raised by p. 45 is 9 into 5, right? So 3 square into 5 raised by p. And this I will write directly, but you need to write this step, and then we'll move on. This is 3 raised by 2p into 5 raised by p. This is the prime factorization of 36 raised by p, and this is the prime factorization of 45 raised by p. Now I need to talk about the HCF. Highest common factor, right? Now let's see. 2 raised by 2p is here. Now, a factor of 2 is not present over here. If 2 is present over here, 2 is not present over here. Do you think in common factor it will be present? Absolutely not. Now, let's see. 3 raised by 2p is here. 3 raised by 2p is here. Right? Do you think in the common factor it would be present? Yes. Do you think in the HCF it would be present? Yes. So this is 3 raised by 2p. Now, 5 raised by p is here. 5 raised by p is not here. So in the common factor only I will not have 5 raised by p. Let alone HCF. So that means this is the HCF. 3 raised by 2p, or you can say 9 raised by 8. Cool. Next one is HCF of two numbers, and the two numbers are 2 cube into 3 cube into 5 square, and the second number is 2 raised by a into 3 square into 5 raised by b. This HCF is equal to 180. Then find the value of a and c. Hurry up. Time factorization is already given of the two numbers, right? I think sufficient time. Now, first number is this, second number is this. And the HCF is given to be 180. Now the thing is prime factorization. See prime factorization, it would be easy. So this is nothing but 9 into 20, right? So 2 square into 3 square into 5. Right? This is the one. Now I know the HCF is this one. So let's see. Now in HCF I have 2 square. Let me look at the numbers. I have 2 cube over here. And here I have 2 raised by a. But in HCF I have 2 square. Now, 2 square is present over here. This must be 2 square in order for the HCF to be 2 square. Right? So, this number should be actually 2 square. In order for the HCF to have 2 square. Now, if this is equal to this, obviously, parts would be same. That means a is equal to 2. Value of a is here. Right. Now, next. HCF has 3 square. Let me check. 3 cube is here, 3 square is here. That means in HCF I would have 3 square. It is fine. I've checked that the question is absolutely right. Right. Now, this one. In HCF, I have 5 raised by 1. Here, I have 5 square. Here, I have 5 raised by b. And it says, HCF, I have 5 raised by 1. Highest common factor is 5 raised by 1. Common factor. That means 5 raised by 2. This has to be 5 raised by 1 because I need to have 5 raised by 1 in HCF. So, this is 5 raised by 1. So, 5 raised by b is equal to 5 raised by 1. b is equal to 1. A is 2, b is 1. That is the answer. Okay. Now we'll be doing some really interesting questions which will actually test whether you understand HCF or not. Because these are tiny questions. This you must have done before as well. But now I'll say whether you understand the concept of highest common factor or not. Right now, if HCF of A comma B is P, where P is prime, then what are the possible values? What are the possible values of HCF of A square and B? Pause the video, think about it. Don't just look at the solution because this you need to analyze it. And I'll be asking the justification as well. Right, let's discuss it. Now, he says HCF of two numbers is given to be P, which is a prime number. You need to find the possible values of HCF of A square and B. Now, HCF निकालना मुझे A square and B. Right? That means I should know the prime factorization of A square and I should know the prime factorization of B. Now, if I am talking about the prime factorization of A square, I should know the prime factorization of A. Right? So from here I get the hint that I will be interested in the prime factorization of A and B. Right? This much was clear. Now he says the HCF of these two numbers is P. Right? Which is a prime number. So do you think P can be present over here? Yes, P can be present over here. Now, let me write B here itself. Now, do you think in B, I will have P present? Yes. Right? But wait a second. Now, here it is P, right? That means P raised to 1. Right? So, in B, I can have P raised to 1. Right? Or I can have P square as well. Why? That is also the case. If A just have P raised to 1, I can put P square in B. Because now in the HCF, it would just be P raised to 1, which is the same as this. Right? Now, P raised to 1, P square, then P cube. If I take the HCF, P raised to 1, P cube, the HCF would have P raised to 1, which is absolutely fine. Then P raised to 4 I can have, and so on. Right? I am taking various values of B. But still the question is not complete. He said the solution is not complete. He said the HCF is P, right? I can have some other prime factor in A. I can have some other prime factor in B. So let me think about it. Now, some other prime factor, let me call that Q. Then maybe I can have R and stuff like that. So maybe I can have Q as denoting prime factors or product of prime factors. Right? As denoted by a single variable which is Q. Now here in B, can I say the other prime factors can be Q itself? Careful. These prime factors and these prime factors, do you think they can be same? If these two prime factors are the same, they would have cropped up in the HCF. So these prime factors or the product of prime factors would be different from the product of these prime factors. So I can denote this as R, some other variable altogether. These two must not have anything in common. Q and R are distinct. Right? Okay. Now, I have taken A as this, I have taken B as this. So, I have kept A constant and have varied the possible values of B. Now, I don't need to talk about A, I need to talk about A square. Right? So, A square, obviously I will square this up. So, A square is P raised to 2 into Q square. Right? Now, consider this and I take first B to be this and I check out the HCF, possible values of HCF. Right? Look at this, look at this. HCF, P raised to 1, P square. In HCF, I would have P raised to 1. Okay? Now, obviously, Q square and R, they are completely different. They will not be common. Got it? Now, instead of this one, consider, I should have written into R everywhere, right? Because you weighted this into R, into R, into R. Right? These are all the possible values of B. Right. Now, A square is this, B consider this one. In this case, what will be the HCF? I think the answer is clear. P square is here, P square is here. In HCF, I would have P square. Now, Q square and R will not have anything in common. So, that is why the HCF is P square. Next, let me consider this B now. So, consider A square and this B. P square is there, P cube is there. P square, P cube. In HCF, that would be P square only. Okay? Right? And Q square and R obviously doesn't have anything in common. Then I'll take A square as this and B as this. P square, P raised to 5. P raised to 4. P raised to 2, P raised to 4. In HCF, what will I have? P square. Cool? Because highest common factor, do not forget that. Now, if I take P raised to 5 over here, there is P square, right? Again, it will be P square. Since this is fixed, even if I keep on increasing the power of P over here, in the common factor, it will have P square itself. Right? Now, possible values, let me check. In the first case, it was P raised to 1. In the second case, P raised to 2. And in all the further cases, it is P square only or P raised to 2. These are the possible values in this case. Which case? When I kept A as constant in the sense I've like made the power of P constant, and here I have varied the power of P. Right? So this was constant, this was varying. Now I can interchange it. I can vary this and make this the constant, which will be the second case. So careful, we are moving on to the second case. Right. Okay, now I'll vary A. So A. First, obviously, P raised to power 1 into Q, the first one that I've already written, right? Then I have P square into Q square. P square into Q itself, because I'm varying the power of P, right? Then PQ into Q. I can have P raised to power 4 into Q. And B remains the same, because in all of these cases, look at this and this, A and B. The HCF is P. Look at these two, HCF is P. Look at these two, HCF is P. So these are the possible values of A. And so on. I'll keep on increasing. P raised to 5, P raised to 6, blah, blah, blah. And into Q to hold it. Right? Now, I'm not talking about A, I'm talking about A square. Right? So let me make the column for A square. So if A is this, A square, this case we have actually discussed it because P square into Q square वाला case है, हम कर चुके हैं जिसमें आया था P raised to 1 in the previous case itself. Second, if I am squaring this up, this will be P raised to 4 and Q square. Now look at this and this, because this is my A square and this is my B. The HCF would be what? P raised to 1, P raised to 4. The HCF would have P raised to 1. R and Q square doesn't have anything in common. They are not popping up in HCF anyway, right? Okay, so P raised to 1. Now, if I square this up, this will be P raised to 6 into Q square. Now, if I consider this A square and this B, these two, the HCF would be again P raised to 1. Right? Next one will be P raised to 8 into Q square. Now, if I consider this A square and B, the HCF would be P raised to 1 itself. Because even if I keep on increasing these parts, this part remains the same, right? And if this part remains the same, in the common factor, I will have P raised to 1 itself. So in this case, only one possible value is there, which is P raised to 1, and which I've already written actually. Right? Now, my first case was, I was keeping A as constant, and I varied the B, the parts basically. Right? Then I kept B as constant, and I varied the A. What is, I varied both of them. Right? Let me put P square here itself and P square here. Do you think I can do that? Vary both of them. The answer is no. The question is why. Now, if I vary both of them, P square, HCF what? HCF is supposed to be P, but now in this case, when you're varying both of them, the HCF changes. Right? So you cannot vary both of them. Right? P raised to 1 has to be fixed in one of these quantities. Either it has to be A or it has to be B. That means we have exhausted all the cases and there are two possible values for the HCF, which is P raised to 1 and P square. Right? Now I'm hoping that you have been able to understand this question. If the answer is yes, so I'm expecting the next question everybody would do it. Right? Right now, if HCF of A comma B is P square, where obviously P is a prime number, then what are the possible values of HCF of A cube and B? Again, I want this kind of analysis that I just did in your notebook. Done? Alright, you can obviously pause the video and move along, but I'll be discussing it. On the board then? Cool. Now, he says HCF of A and B is P square, where P is a prime, and possible values of HCF of A cube and B. That means indirectly I need to talk about the prime factorization of A and B. So let me put it, A and B. Right? Now, HCF is P square, that means P square can be present over here. P square can be present over here. Right? Again, I will make the same case. When I am keeping A constant and I will vary the power of P in B. So P square के साथ P की बात सकता है. Right? Again, HCF would have P square. Then P raised to 4, then P raised to 5, then P raised to 6, P raised to 7, P raised to 8, and so on. Now we need to talk about the other prime factors as well. So if I write these prime factors, or the product of primes as Q, I cannot write Q over here. Right? Same factors cannot come because I have to make sure that the HCF remains P square. So this is R. So into R, into R, into R. So in all of these values, R is there. Right? Now, he is talking about the HCF of A cube. He's not talking about A. He wants A cube, so cube it up. So A cube is, now cubing karoge, so P square का cube, so that is P raised by 6 into Q cube. Now consider this A cube and this B, first case. This B. What will the HCF be? I think answer is clear enough. Here I have P raised by 6, A has P raised by 2. In the HCF, in the common factor, the highest common factor, I would have P raised by 2. Obviously, Q cube and R, they do not have anything in common. Right? Now, I will take my B to be this. Consider this and this. HCF would be, here I have P raised by 6, here I have P raised by 3. Highest common factor would have P raised by 3. Done? Now consider my B to be P raised by 4 into R. So P raised by 6, P raised by 4. HCF would have P raised by 4. Now consider this one, P raised by 5, P raised by 6. The HCF would have P raised by 5. Then P raised by 6, P raised by 6. The HCF would have P raised by 6. Right? Now, P raised by 7 into R. This is P raised by 6 into Q. P raised by 7, P raised by 6. The HCF would have P raised by 6. Okay, careful. Now again, P raised by 8 is here, P raised by 6 is there. The HCF would have P raised by 6. Now if I take P raised by 9, there it is P raised by 6. The HCF would have P raised by 6. Right? Because highest common factor, this is not changing now. You can increase the power no matter how much you want to. But highest common factor would be stuck at P raised by 6. So P raised by 6 and so on. That means P raised by 6 is repeating from now on. Right? So possible values. Either it can be P square, or it can be P cube, or it can be P raised by 4, or it can be P raised by 5, or P raised by 6. When I have kept A as constant and B as the varying quantity, I have 5 possible values. Right? Let me interchange it. Now I'll vary A and keep B as constant. Let's check what happens in that one. Second case. Right? Now I need to vary A. So I can have P cube into Q, then P raised by 4 into Q, then P raised by 5 into Q, and so on. Now these are all A. I want A cube, so let me make the column for A. When A is this, A cube is P raised by 6 into Q square. Then let me write as P raised by 9 into Q square. Then P raised by 12 into Q square. Then P raised by 15 into Q square. I am hoping you Q. All of these should be Q. In the previous question, did I write square or cube? In the previous case. It is cube, obviously I am cubing it out. Right? Okay. Now, and so on. Now, first case I've already considered in the previous one. So consider the second one. When A is this, A cube is this, and B is the constant one. These two must have the HCF as what? P square is here, P raised by 9 is here. That means the HCF should have P square. Right? Obviously Q cube and R doesn't have anything in common. Right? Next, I'll take A to be this, that means A cube will be this one. Now, P raised by 12, P square. The HCF would have P square. Right? Now, if I take P raised by 15 and P square, the HCF would have P square. And so on. Because what is happening, the power of P is increasing, but this is constant. That is why in HCF, I am only having P square. So, in this case, only one possible value is there, that is P square. Right? Which I have already mentioned. So, answer is the possible values of HCF of A cube and B, that is P square, P raised by 2, P raised by 3, P raised by 4, P raised by 5 and P raised by 6. Right? So, with this, we'll end this lecture. I am hoping that you understand the nuances and the importance of HCF. Because when this type of question comes, the very concept of HCF should be clear in your mind. Alright, so that's it for today. Home assignment would be uploaded. Please do it. Thank you and I will see you next time.